Okay, YouTube, in this video we're going to look at a broader method for solving quadratic equations that involves a process called completing the square. And so I'm going to take you through this process of completing the square and then talk about how really it's just solving quadratic equations by using square roots. But there's a little bit of necessary algebra that goes into it before we can use square roots to solve it. So let's go ahead and read through this. This is kind of an important statement to start with, but we say if x squared plus bx is a binomial, that is, we're starting with some quadratic thing, ax squared plus bx plus c, where specifically we're saying that a is equal to 1. Okay, so we have x squared plus bx, and we're saying that specifically c is equal to 0 here. We say then by adding b over 2 squared, it says which is the square of half the coefficient of x. So in other words, if you take this middle term and you cut it in half and square it, and you add that on to the initial trinomial, we say that what you really get here is a perfect square trinomial. And not only that, you notice here I say 1x squared plus bx. If we add half of this b term squared to this expression right here, and really this is kind of like our c value now. If this is true, then what we'll get is a factorable expression that factors into what we call a perfect square binomial, or a binomial times itself. And the nice thing about this is essentially that this is something that we could take the square root of and just get what's on the inside, okay? So what I want to do before we do anything else is this. If I were to load you up with three expressions here that are all in this form x squared, 1x squared plus bx, could we determine what should we add to this expression so that it would become what we call a perfect square trinomial, become one of these? And the reason we say this is a perfect square trinomial is because it can be written as a perfect square of some binomial. It's a perfect square number. Just like 9 is a perfect square of 3, we're saying that this expression is always a perfect square of this binomial right here. Then what we're going to do is we're going to write and factor the trinomial. So let's take a look at these three right here, and then we'll talk about how we could use that method to actually solve some quadratic equations that are not factorable in the first place. So we say letter A here, it says x squared plus 6x. Now I notice here, first of all, my a value is 1 and my b value is 6. So it is clutch, it is key that this a value is 1 to begin with. And I'm just going to go ahead and point this out that for all three of these expressions, at the very least, a is 1. But we say, since we know b, what we want to do is find out what would I want to add on to this expression such that this becomes what we call a perfect square trinomial. And the answer to that question really is always, it's half the middle term squared. So if we were to take 6 and cut it in half, we say 6 over 2, and then square it, we really get 3 squared, which becomes a 9. So now that I've got this perfect square trinomial written, what I want to point out here is this. I mean, if I said, could you factor this? I mean, really, what it becomes is this idea that, well, yeah, it's a trinomial. Let's try to factor it. The two factors of 9 that I can think of that add up to be a positive 6 are positive 3 and positive 3. The idea is going to be, though, that we could write it like this. We could say x plus 3 really squared. And that's important because, again, if we're going to be solving quadratic equations, we want something we can just take the square root of, and the square root of something squared is just the stuff on the inside. So again, before we move on to these next two, we say half the middle term squared is equal to this last term here. Then it will factor, and not only will it factored in this case into x plus 3 squared, where the number or the value of the thing that was in here was that number that we squared to get this 9 in the first place, or you could just say half the middle term. So looking at this next expression here, it looks like we have x squared minus 5x. What would I really want to add in right here to make this a perfect square trinomial? When keeping in mind that if we were to take half the middle term, which is negative 5, and square it, our power of a quotient rule says we would square the top and the bottom of this. So really what we would get is 25 over 4. And so this would now be a perfect square trinomial, and furthermore we could say, well, this totally factors into the square of a binomial. Not only that, what would go in here is half of that middle term, which was what we squared to get this last term here in the first place. So we would just say minus 5 halves, negative 5 halves. And then for this last expression here, we already have a fraction. We have this x squared plus 2/3 x plus, now what would I want to add in here? Again, we would say really it's half the middle term squared. Now one thing I do want to comment on is if you take half of a fraction, that's the same thing as multiply by the reciprocal of 2, which is a half. You would get this. You get basically a third, or we could say 2/6. So the idea is this. If you ever take half of a fraction, you can double its denominator. So knowing that, we could say, well, 2/6 squared is what I would want to put right here. Or in other words, 1/3 squared. And again, power of a quotient rule just says square the top and bottom of that quotient. So we would get 1 squared over 3 squared, which is a ninth. And furthermore, this would have to factor now into the square of a binomial, where half the middle term would be what we put in here, which in this case was 2/6, or I'm just going to write 1/3. This would be our squared binomial. So now, knowing that we can form our very own perfect square trinomial out of the blue, we can just make it. What we could do is use that fact to help us solve an equation like the one you see up here. So, using what we know from previous videos, we would say, well, if I wanted to solve this by completing the square, let's just say I was asked to solve it in the first place, this x squared plus 4x minus 1 equals 0. The first thing we do is set it equal to 0. The second thing we would do is, hey, ask, can I factor this? So it is the case that this is unfactorable in this video. I also notice that we have an x to the second term and an x to the first term, so solving by square roots is out of the question at the moment. So here's our method for completing the square. I'm going to take you through a step at a time. We say boot the constant. So here's the deal. The very first thing we're going to do is we're going to rewrite this in this form x squared plus bx on the left. So what we would get is when I add 1 to both sides, add 1, we get this x squared plus, in this case, 4x, which is our b term here, and this is going to be equal to 1. Now you notice I left myself a little space here because what I'm really going to ask is this. What could I put right here to make this a perfect square trinomial? Well, knowing what we know about perfect square trinomials, it's going to be equal to half of our b term squared. So half of a positive 4 is a positive 2. Positive 2 squared is a 4. So now we say add this, b over 2 squared, both sides. Thing is, when you add something to the left side of the equation here, we're still responsible for adding it to the right. And so now this third step is going to be this. Factor the perfect square trinomial is what we'll do next. So this, we know it factors. We know it's got to factor. And furthermore, I know what goes in here. It's half that middle term. So we'd say, well, this has got to be a positive 2. And on the right side, I get 5. So what makes this unique is just like in the last video, now you notice that we have something that is of the form some algebraic expression in x squared equals a number, where we can just take the square root of both sides. So now that I've completed the square, which is really what we just did, we're going to take the square root of both sides, and we end up turning this out. We say x plus 2 equals, now, importantly, plus or minus the square root of 5, and then I'll subtract 2 from both sides, which leads us to the conclusion that x equals negative 2 plus or minus the square root of 5. So it'd be very easy to check. I don't want to say easy, but you could check it by plugging it back into the original expression and seeing that you get 0. And also you could go graph this and say, well, look, the x-intercepts are at negative 2 plus the square root of 5 and positive 2 plus the square root of 5. So the last step here was basically square root, square root and solve. So I'm going to try this again. Now, what's different about this next expression here is that, I hope you notice this, for our ax squared plus bx plus c, it's already equal to 0, is the fact that we have an a value that is not 1. So we're going to start the same way we did last time, which is boot this constant to the right side. Our goal is to look, like x squared plus bx just by itself. But what I want everybody to notice is that in this video, in this example rather, we get something that doesn't look like x squared plus bx, it looks like ax squared plus bx. So the stipulation is, if we're going to make this a perfect square trinomial, this must be a 1 for our a value. So the trick here is this. We are going to factor out the leading coefficient. Factor this out. And so what we end up with is, in this case, 2 coming out front, and now this becomes a 1x squared. Now because factoring this out is kind of the opposite of multiplying, it's like dividing, we're going to say, well, what's left here in the middle is 3 halves x. Because if I were to redistribute this, you'd see that I get this 3x back. And then I'm going to write plus blank. And on the right side, because I'm going to add the same thing on the right, I have to add that same blank. So what's important to note here is this. Would I really be adding this blank term right here, kind of like up here we added 4 to both sides? Do I add the same thing? Or think about this, am I really adding 2 times everything on the left here? So the important thing to note is that I'm really adding 2 times whatever's in this green spot right here. Here's the green blob on the right. So we have to add 2 times that to the right. So the only difference here is we're adding 2 times this number because of the 2 out front, whereas up here we added 4 to both sides because really we already had a 1 out front, and 1 times 4 is 4. So now on the left we get this. We get 2 times the quantity x something squared. Furthermore, I suppose we need to come up with this value here before I start factoring this, but if I said half of 3 halves, remember half of a fraction, we can double its denominator. So I get 3/4. And if I take 3/4 times 3/4, we get 9/16. So I need to add 9/16 to the right over here as well. So what we get now finally down here is going to be 3 over, not 2 this time, but 3 over 4. And it's going to be positive. So we say positive 3/4. This thing squared is equal to 4 plus now 2 times 9/16, which is really 2 over 1 times 9 over 16, which are 2 and our 16 cross cancel, and I get an 8 here. So we say plus 9/8. Now, I never said completing the square was my favorite method, but it certainly is a method that we're going to put to use here and when we find the quadratic formula in the next video. So at least let's find a common denominator here, which is in this case is 8. 8 on both sides, we say, or on top and bottom, we say 8 times 4 is 32. 8s plus 9/8, which comes out to be a grand total of 41/8. Okay? So in this case, what we have left to do is we're going to divide both sides by this 2. And again, I'm dividing a fraction by 2. So I'm running out of room here a little bit. But we'd say, ignoring this part here in the middle, we'd say all of this equals this. We've gotten rid of this right here, and we've isolated the squared thing. That is, we have x plus 3/4 squared, and on the right side, we're taking the square root of 41 over the square root of 8. So now the final step here, not taking the square root yet, we say 41 over 8. But the final step will be to take the square root of both sides. And so we get x plus 3/4 is equal to the square root of 41 over the square root of 8. And then our final move will be to subtract this 3/4 to this side. So we get x equals negative 3/4. And we have plus or minus in front of our radicals here, the square root of 41 over the square root of 8. So that is our process for completing the square here. Essentially, we need to simplify what you see right here. But for right now, we're just going to leave it as is and say that's the process you go through to complete the square. Cheers.